This tutorial will be fairly basic. We're going to look at how to use the trace feature and or table features of your calculator to examine the limit of a function as it approaches a certain point. This is particularly useful when you have discontinuity, which is the case in this example, example 2, in which we have a rational function, x squared minus 9, f of x equals x squared minus 9 over x minus 3. And we have an implied domain because of that expression of x in the denominator, in which x cannot equal 3. But we can still examine the limit as x approaches 3. So the first step is to enter the equation into the y equals menu. Let's put the numerator and denominator in parentheses so we get the correct division. So parentheses x squared minus 9 all over parentheses x minus 3. Now if you use the standard window, zoom 6, you get something that looks like this. And we can't really see where x equals 3, so let's change the parameters of our window to zoom in on that point. Let's change the minimum x to 2.8 and the maximum x to 3.2. And if you go back to the graph, you can see at x equals 3, there's this little hole here, which coincides with x not being able to equal 3 because x minus 3 is in the denominator of our rational function. So let's go to trace, and it's starting us out at the point where the function is not defined at x equals 3. But what if we go just above that? If we go just over 4 1,000ths above, we get just above 6. And if we go just below x equals 3, we get just below 6, which indicates that the limit as x approaches 3 of x squared minus 9 over x minus 3 is 6. Now we can also use the table feature to do this. If you go to second table set, let's start our table at 2.95, and let's change the increments, which is the delta table, that's the change in increments, how often it shows the value of the function, to 0.001, 1/1000. Now go to second table, which is just above graph, and we can see that as we scroll down, as x gets larger from the negative side of, or from the left side of x equals 3, that y, our function, is approaching 6. At x equals 3, it's not defined. If you go just above 3, it's slightly above 6, which again indicates that the limit as x approaches 3 of f of x equals x squared minus 9 over x minus 3 is simply 6. And that's all there is to it.